Hello friends, welcome back to my YouTube channel MS Maths. In this video I will explain you the SN and QET set. So these both are very important set. This is what the set of permutation and set of we can say the Q8 set. Okay, Q8 set is something known as quadrilateral set, or we can also say this is as QET because it has 8 elements that I will show you. So basics of group that I will explaining in this series. This is what the part 7 of this series. This is helpful for IIT JAM, CUET, NBHM, TIFR, CSIR-NET and GATE. My name is Manoj Solanki, and please follow the YouTube channel and the playlist for all the kinds of basics and the courses of these helpful examination. And I have uploaded all the videos related to the BSc Mathematics, M.Sc Mathematics, and I'm trying to upload here the series and the basic concepts of the higher mathematics. So I'll start with SN set. SN is nothing but set of permutation. This is going to be, yes, it is going to be set of permutation. Now, what do you mean by permutation? That I will explain you. So first of all, which kind of elements will it contain, or what kind of element will be in this set? That is nothing but SN be the set of 1 onto mapping from set containing n element to itself. N element to itself, the number of elements. So the number of elements in SN, that is what n factorial. Okay, that I will explain you. So what is the meaning of 1 onto? So 1 okay, 1 and onto. So first of all, you should have idea about what is the meaning of 1. Okay, what is going on? Wait. Yes, 1 and onto. So 1 means whenever you are defining any of the function, let's say this is your a and this is your b, you are defining a function from a to b. Okay, this is your, wait, this is your domain. I don't know why it is happening. Wait. Yes, let's say it is your domain and this is your codomain. Okay, so 1 means if you are taking any of the element from domain x1 not equals to x2, then f of x1 should not equals to f of x2 in codomain. Okay, onto means whatever the cardinality, or whatever you are saying, that if you have n number of element in the codomain, then each and every element should have its pre-image in the domain. It means each and every element should be connected. No element should be remain in this particular set. That is what they known as codomain. It means that you can say the range of f should be equals to the cardinality of codomain. Okay, this is the definition of onto, and this is the definition of 1 that I will show you. Okay, so construction of S1. So this is what S1 n. Okay, this is from a set which containing 1 element to 1 itself, mapping itself. Now 1 and onto, it is 1. Okay, so my domain have element 1, here it has element 1, this is my codomain, and a mapping I am defining, that is what F1. So F1 1. So 1 means mapping should be only one mapping. So 1 element is connected to 1, and each and every element of codomain should have a pre-image. Yes, that is satisfying. It means that there is only 1. So mapping, this is what the permutation, this is called permutation. It means 1 maps to f of 1. So let's say my x1 is equals to 1, then f1 x1, that is nothing but f1 1, that is 1. So 1 goes to 1. So this is what 1 goes to 1, that is called identity, and this is my S1 set. So how many elements are there? That is 1, and I told you the cardinality of this set is nothing but n factorial. So it means it is what 1 factorial, and the cardinality of this set is going to be 1. Now I will tell you how we can construct S2. Just take here 2 elements are there, 1 and 2. Here it is 1 and 2. This is my domain, and this is what codomain. So from here, if I will define a mapping F, so first mapping like this 1, and this is what 1. It means 1 goes to 1, 2 goes to 2. Let's say this is my F1. I can define same mapping as like this 1, 2, this is 1, this is 2. Now I will define, this is what my F2. 1 goes to 2, 2 goes to 1. That is also 1 and on 2. That is also, it means it is covering totally this set. Yes. Connecting 1 to 1, yes, 1. So means two pairs can be there. So from here I can say 1 f of 1 can define like this, 2 f1 of 2. Okay, this is what f1 of 2. So it means this permutation is nothing but 1 2, 1 goes to 1, 2 goes to 2. I will just write it as identity. This is nothing but identity. 1 goes to 1, 2 goes to 2. This is nothing but identity. Or let's say I will write with this with E. I will denote this with E. This is my first element. Now what about this? I will just like 1, and this is what f2. So f2 of 1, 2. Then f2 of 2. What is the image of f1? Image of f1 is 2. That is what 1 goes to 2. Image of 2, that is my 2 goes to 1. So it means from here 1 goes to 2, 2 goes to 1. So this is what 1 goes to 2, 2 goes to 1. So this is my second element, 1 comma 2. So this is what the set. So the set S2 is nothing but, okay, from here, yes, so from here it is what identity and 1 comma 2. 1, not 1 comma 2. If you write 1 2, that will be accepted as 1 2. This is what it has, 2 element, means 2 factorial. So the cardinality of S2 is 2 factorial, that is what 2. So it contains 2 elements. This is what the frame. Next, now can I construct this one? Yes, I can construct. So just tell me from here. I will take the mapping 1 2 3. Okay, from here 1 2 3. So from here 1 2 3, 1 2 3. Then 1 2 3, 1 2 3. So I'll just define all those elements this. So can you identify how many elements will be there, so that I can make the diagram in like that? Yes, S3. So the cardinality of S3 is 3 factorial. So 3 into 2 into 1 is going to be 6. It means there are 6 different mappings. So I will define with this 6. Okay, with 6 number of diagrams. Okay, now just see here. Now from here I will define the mapping. So first mapping is very simple, 1 to 1. From here to here, here to here. That is what your 1 goes to 1, 2 goes to 2, 3 goes to 3. Means simple identity. That's it. Okay, now 1 goes to 2, 2 goes to 1, but 3 goes to 3. 1 1 on 2. That is what 1 goes to 2, 2 goes to 3. Sorry, 2 goes to 1, 2 goes to 1, 3 goes to 3. How will you write this? 1 goes to 2, 2 goes to 1. You will just close it, and here you will write 3. This is nothing but 1 goes 1 2. It means it is by default that it means 3 goes to 3. Okay, no need to write it. This is called, if you have any of the element which contains 2 tuple, one like it has 2 element in a tuple, that is called transformation. That I will explain you later in the group theory course. Okay, now from here what can happen? Yes, my 1 goes to 3, 2 goes to 1, and 3 goes to 2. Okay, sorry. So from here what happened? 1 goes to 3, 2 goes to 1, and 3 goes to 2. Or otherwise I can just make it as a simple in the same series. Okay, 1 goes to 1, 2 goes to 3, 3 goes to 2. That can be also, yes. So means 1 goes to 1, 2 goes to 3, 3 goes to 2. So from here 1 closed, 2 goes to 3, 3 goes to 2. So it means it is nothing but 2 and 3. Now from here if I'll take like this, 2 goes to 2, 1 goes to 3, 3 goes to 1. It means 1 goes to 3, 2 goes to 2, 3 goes to 1. So from here it is 1 goes to 3, 3 goes to 1 and 2. So I can write simply 1 and 3 here. Clear? Now from here 1 goes to 3, 3 goes to 2, and 2 goes to 1. That is what? See, 1 goes to 2, sorry, 1 goes to 3, okay, 2 goes to 1, and 3 goes to 2. So it means that if we write 1, 1 goes to 3, 3 goes to 2, 2 goes to 1. See, here 3 goes to 2, 2 goes to 1. We'll make the, let's say, permutation. This will look like the permutation. Now from here 1 goes to 2, 2 goes to 3, but 3 goes to 1. So it is what, 1 more. So 1 2 3, 1 goes to 2, 2 goes to 3, 3 goes to 1. That is what the 1 goes to 2, 2 goes to. So there are 6 elements are there. That is what I will write the element in S3. That is nothing but your identity 1 2, 1 3, 2 3. Okay, 1 2 3 and what, 1 3 2. So these are the elements here. Now one thing that I want to show you, there are particular types of element. Just see here, there are particular types of element. Here it is what, okay, first type element, second type element and third type element. We are defining these types using the cycle decomposition of S3. Now you will say, what is the meaning of cycle decomposition? Okay, wait. Yes, what is the meaning of cycle decomposition? So the meaning of cycle decomposition is what? This is my S3, means it is 3. How can I decompose this 3? As 1 plus 1 plus 1, sum should be 3. 1 plus 2, sum should be 3. And 3 is equals to 3. Means there are 3 kind of different shapes of element, different types of elements. So first one is identity, second one is what, identity, or let's say 1 and 2, that is what, AB, and third one is your ABC. So this is what, identity. These are AB type of element, AB. These are ABC type of element. Okay, so these are the, okay, now if I will tell you how many, let's say, okay, let's say if I will tell you like S4, about the S4, and how can we find for S4? So how many, first of all, how many elements will be there? So S4 have elements, that is what, the 4 factorial. Okay, so the cardinality is what, the 4 factorial. It means it will be 24. So I can't derive the 24 element, but simply I can give you the types of the element, what kind of types it will be. So let's say it is what, S4 means 4. So first the cycle composition is 1 plus 1 plus 1. So identity will be there. So second will be 1 plus 1 plus 2. So it is 4, it is 4. 1 plus 3, it is again going to be 4. 2 plus 2, it is again going to be 4, and 4 it is also again going to be 4. Now these are the types of, other than this type. So it means identity will be there. This is the meaning of AB type of element will be there. This is the meaning of ABC type of elements will be there. This is the meaning of ABCD type of element, 2 ABCD, and this is what, ABCD types of elements will be there. Now if you will say how many elements of this, okay, how many elements of this type, how many element of this type, how many element of this type, how many element of this type, that have another story that I will tell you. Okay, I'll start with S3 here. Let's say this is my S3. Cycle decomposition is 1 plus 1 plus 1. Okay, 1 plus 2, and this is what, your 3. Now if I will tell you how many element of order 2, it means, okay, how many element of order 2 means that who has the element, that I will explain in the group theory. Order means that if you will multiply that element and how many times you will multiply, then you will get the identity. That is what the meaning of order. It means, okay, what kind of possible order for this, like for the element of S3, that is what the LCM of the, if you will take the LCM, of 1 1 1, then that is nothing but 1. It means first order element will be there. If we will take the LCM of 1 and 2, means 2 order element will be there. If we will take the LCM of 3, means 3 order element will be there. Now how many elements? So first, so 1. So how many element of order 1? So if you will take S3, then simple, number of element of order 1. How many elements? That is what, the 3 factorial. Okay, see the cycle decomposition, that is what, 1 plus 1 plus 1. Okay, just write 1 here. How many times 1 repeating? 3 times. So 1 power 3 into 3 factorial. Whatever the power, take the factorial. Then it is what, 3 factorial divided by 3 factorial, that is going to be 1. So one element will be there which have order 1. Now second, number of element of order 2. it means that what, 1 plus 2, so it means 3 factorial. Order of element, order of set divided by 1 repeated 1 times, 1 power 1 into 1 factorial into 1 factorial into 2 power 1 into power factorial, that is what 3 factorial divided by 1 into 2, that is what 3 into 2 divided by 2, it's going to be 3, means what, 1 2, okay, 2 3 and 1 3, these are the 3 element of order 2. Now if 3 order 3, okay, number of element of order 3, that is what the 3 factorial divided by 3 power 1 into 1 factorial, that is what 2 elements, that is what 1 2 3 and 1 3 2. These are the, like, this is the way that you can find the number of or number of element basically. Okay, now if we'll say what is the, okay, how many elements are there of order, the like LCM order 3, this has order 3 element, so that is what the 4 factorial 1 into 3, so that is 1 into 3 power 1 and 1 factorial, again here 1 power 1 and 1 factorial, that is what the 4 into 3 into 2 divided by 3, it means 8 elements which have order 3. If I will say how many elements have order 2, so you will take the LCM of this, so the LCM of 2 comma 2 is again 2, and again the LCM of 1 comma 1 comma 2 is also 2, so you will find the number of element of this type, number of element of this type, and then add both that, then you will get the order of how many, exact number of order of 2 element. Okay, that is what the case here. Now come to the Quaternion CUET. Okay, not quadrilateral group, that is what the Quaternion group. I think initially I just told you the like quadrilateral. So Quaternion means that CUET, it has 8 elements, plus minus 1, plus minus I, plus minus j, plus minus k. Now how I will define these? So this is what the simple criteria, I square, j square, k square, if you will take the square it will be 0. I, j, this is what the simple story, I, j and k. If you will go like this, I into j is equals to what, I into j is equals to minus j into I. Okay, from here it is minus j into I, that is what the k. Okay, j into k, that you will take in your vector like calculus. That's the simple story here. You will define like this, and the order of this element or this set is, or the cardinality of this set is going to be 8. That is what the simple story here. This is all about the Quaternion group, and that I have explained with you the permutation group or set of permutation n, that is what the SN, that is very important topic. So thanks for watching my video. Keep watching MS Maths. We'll meet you in the next video. Thank you. Bye bye.